I just don't understand this. I wish someone could help me find the trig values and side lengths of these special right triangles.
I like to gig frogs, like to gut hogs, like to swim in the creek with my bird dog.
Hey, can you help me with my homework?
Sure thing, Bo. Well, Mikey, let me help you out with the first triangle. These two lines right here mean that those side lengths are equal length. That also means that these two angles are also equal. Do you know what the sum of all interior angles of a triangle equals to?
Yeah, 180.
And do you know how many degrees a right triangle is?
90.
Okay, so what we do is 180 minus 90 equals 90. Since there's 2, we're going to divide it by 2 to get 45 degrees for each angle. Since we've determined the angles, which is 45, 45, 90, we know that it is one of 2 special right triangles. This special right triangle has specific side lengths and specific trigonometric values. These will be the same in all cases, so an easy way is just to remember them. The hypotenuse will always be the square root of 2. Each side length will always be 1. And
Got it, Bo?
Got it, Bo.
This next triangle we have is called a 30, 60, 90 degree triangle. 30 degree angle, 60 degree angle, and a right angle. The hypotenuse of these triangles are always 2. The side that's adjacent to it with a 30 degree angle has a side length of square root of 3. The last remaining side is half of the hypotenuse, so it's 1. An easy way to remember this is that the side adjacent to the hypotenuse with the 30 degree angle always has a side length of square root of 3. So square root of 3 for the 30 degree angle. And the other side is always 1. There are 3 trigonometric values for angles: sine, cosine, and tangent. Sine equals opposite over hypotenuse. Cosine equals adjacent over hypotenuse. Tangent equals opposite over adjacent. An easy way to remember this is SOHCAHTOA. Sine and then opposite and hypotenuse. Cosine, adjacent over hypotenuse. TOA, tangent, opposite over adjacent. You use these, opposite over adjacent, adjacent over hypotenuse, and opposite over hypotenuse, to find the sine, cosine, and tangent values of triangles and angles. For example, this will be a 45, 45, 90 degree triangle. We already know the sides are hypotenuse is square root of 2, and the other sides are 1. So if we were to find the sine of this angle, it would be the opposite, 1, over hypotenuse, square root of 2. Another example could be used during the 30, 60, 90 degree triangle. If we were looking for the tangent of 30, we could find the opposite, which we know to be 1, over the adjacent, which is square root of 3. So it would be opposite 1 over adjacent, square root of 3. For cosine, we could also use this on the same 30, 60, 90 degree triangle, or any triangle for that case. If we were looking for the cosine of 60, it would be adjacent, which is 1, over the hypotenuse, 2. So, alright dude, so you remember all the information about trigonomic values of 2 special right triangles?
Yeah.
so, always remember the side lengths of your special right triangles and their trigonometric values. SOHCAHTOA.
Stay in school and don't do drugs.
He's a shirt off his back, give you his last time. Strong.
Right angle is
90 degrees.
He's in need to move
So,
something you can
180
use my truck.
minus
He's an overtime worker when the bills pile up. Everybody